Okay, hi everyone, welcome back. I gave you some tips on the Hangman assignment in the previous two videos. So we've covered one and two, not covered, but of course you got the idea for one and two here. And I'm in this video I'm going to talk about the third item here, which is displaying statistics and specifically displaying the statistics in descending order from highest score to lowest score. Okay, so in this assignment, you are not required to use structures. Okay, so we haven't learned about this yet, so you're not required. Of course, you can if you wish. So, in order to implement this requirement, we need somehow to keep the name and the score of the players. Okay, so you can use a structure if you want, but I'm going to explain how you can do this with parallel arrays. Okay, so you can have one array which contains this is a two-dimensional array or one-dimensional array of strings which contains the players' names, and then you can have a parallel array to keep the scores. Okay, that's a one-dimensional array of integers. So the parallel here is that the player at location at index 0 corresponds to the score in the other array at index 0. Okay, so we have corresponding names and scores. So let's get into our compiler here and see what we can see. Let me kind of comment out this code using if def, let's call it Hangman oops and if. Okay, so let's declare two parallel arrays. Okay, so assume that you're storing the names in an array called player names, and here you can, I think it's size 50 rows. Okay, so let's assume 30 columns for the name, and I'm going to initialize it right now so it makes my life a bit easier, but you of course will not initialize this array because you need to be loading it as the players play your game. Okay, so I'm going to assume that Bob, Bill, and Ben are here. So I assume that I have 3 players. And I also need an array of integers to store the player scores. And of course this is the same size, 50 rows or 50. Right now this is a one-dimensional array, and I'm also going to initialize these to 34, 50, and 100. Okay, so of course you need to figure out how to keep a counter to keep track of how many players we have. Okay, so let me call this number players. Okay, I'm going to set it to 3 right now, but you need to use a counter and add 1 each time a new player plays the game and store his score in the player names, in the name in the player names array and the score in the player scores array. Okay, but for now I'm going to take this for granted, and I'm going to show you how we can use a sorting technique to sort the names and the scores. We need to sort by descending score from highest to lowest. Okay, so that's what we're going to concentrate on. Okay, so there is a bubble sort algorithm in the book for sorting, and this one is very similar. I'm going to show you the selection sort algorithm. And to do this, I'm going to create a function. So I'm going to do this through a function. This is going to be void, and I'm going to take the both arrays here, the player names and scores, and sort. And as you know, when you pass arrays to functions Any changes you make to the arrays inside the function, those are reflected back in the calling program. So let's begin with the name, the function name, player sort by score. Okay, this is descending score from highest to lowest. So it's going to accept the two-dimensional array of characters, or the player names. And I'm going to also pass in the number of players I have. This is why I'm not setting this to a fixed number, okay? But you can set it to a fixed number. It doesn't matter in this case, okay? But I'm going to pass it in, so I'm going to avoid this. And then we have the player score array. So this is an integer. So player score. Again, no need to pass in the rows. And then I'm going to pass in, of course, the number of players here. Number of players. Okay, so this is the way that this selection sort works. Similar to bubble sort, we need a temporary variable to store the score and the name, okay? Because here, similar to bubble sort, we're going to be swapping, okay? So if we find that a score is greater, we need to move it up in the array in the first index. And in that case, we need to swap positions just like in bubble sort, so we need temporary variables. Remember, whenever you want to swap two variables, you always need a third variable. So we need two temporary variables, one for the score, so it's an integer, and one for the name, okay? Because we need to swap both so that all the scores and the names are aligned. Temp name of 30 to store the name, okay? So this works just like bubble sort. It works as a nested for loop, two nested for loops. So you can check this out online. So for I from 0 to up to the number of players, as long as I is less than the number of players. I'm not going to go over how this works right now because I don't want to make the video long. But you can look this up, okay? So online of how it works. For int j is equal to I plus 1, j less than number of players, j plus plus. Okay, so here we need to check if the player score at location j is greater than the player score at location I. So in this case, we need to change these. Okay, so we change them with the swapping technique, swap scores. Temp score is assigned to player score of I. Player score of I is assigned to player score of j. And player score of j is assigned to temp score. And then similarly, we need to swap the names. Okay, so notice that the condition checks the scores, and based on that we swap or not. So if we need to swap, we also need to swap the names to keep the arrays parallel. So to swap names, we cannot, just assign temp name assigned to player name I. Okay, we can never do this with strings. Remember, we can never use the assignment statement for strings except when we're declaring the string variable. Okay, just at declaration. So here we need to use the string copy function. So we string copy the player name of I to temp name, and then let me copy this. String copy player name J to player name I, and then again string copy player name J temp to player name J. So temp name. Okay, and that's it. And once this finishes execution, the arrays are sorted. So let's test this out. So let me call this function. First of all, let me create the function prototype here. Let me copy this above main because I had it below. So just copy that first line of code and you're ready. Okay, so this is the function prototype, and let's call it now. So we're ready to call it player sort by score and pass in the player names. Okay, so when we pass in 2D arrays or 1D arrays, we just pass the name of the array. So we have player scores and number of players. So once this function is called, the arrays are sorted. So let's print them out and see what's going on. So initially notice that these are sorted well, these are not sorted. Let me change this. Let me make it 50 and make this 35. Okay, so what we want is we want Ben to appear first because he has 100. Then we want Bob, and then we want Bill. Okay, so let's test this. For int I is 0. Let's go through the arrays and see what is going on. And I is less than the number of players. Plus I. And I'll just print out everything on one line here. So let's print the name, some tabs, and then the score. So we have player names and player scores of I. Okay, so let's see what is going to happen. Let's run this. I have some errors. Many errors. Okay. Okay, it says player name. Did you mean player names? Yes, I did. Okay, so player names is the array. So let's correct our errors. And here we go. We have, notice that everything is sorted in a descending order. So Ben is first with 100, then we have Bob, and then Bill. Okay, so I hope this also will help you in your Hangman submission this week. Thank you so much. Bye-bye.